So let's refresh our memories back to Thursday when we were doing expanding and condensing. When I look at something like x to the third raised to the fourth power, I'm thinking about expanding it. That's like writing x to the third 4 times. Okay, this entire thing is raised to the power of 4. So that's like x to the third times x to the third times x to the third times x to the third. Now, each one of those x to the thirds is like 3 x's next to each other. So I could rewrite this as x times x times x times x. Each one of those x to the thirds is 3 x's, right? Now, if I condense that back together, if I squish them back together, how many total x's did I end up with? The answer should be 12. So what do we think our rule is? If we raise an exponent to another exponent, what do I have to do to figure out how many I have? Read. Not add them. 3 and 4 don't make 12. We multiply them. So if I have an exponent raised to another exponent, we're going to multiply those exponents. Now that is different than what we did yesterday. Yesterday, your problems looked like this. I'm going to write them up here. It would have looked like x to the third times x to the fourth. We add those together to get x to the seventh. Not quite the same. We see the difference? Okay, so this is our power rule. It's very straightforward. If I have p to the third raised to the second power, what does that give me? Cody. P to the sixth. 3 times 2 is 6. Now, example 2, I got a little bit more going on. The x to the second power kind of just stays where it is. But I then have x to the sixth raised to the negative fourth. That negative 4 only is talking about the x to the sixth power. What's x to the sixth to the negative fourth? X to the negative 24. Now, is this simplified all the way? No. What do I still have to do to this? We're going to combine them together. So x to the second and x to the 24th have the same base. We can add their exponents together to get x to the negative 22nd. Am I done now? What do I still have to do to it? We got to make it into a fraction. Because of this negative exponent right here, this is going to look like 1 over x to the positive 22nd. Any questions on that? Okay, example 3. M to the negative second times m to the negative second to the fifth power is what? M to the negative 10th. Is that simplified? What's the simplified form? 1 over m to the 10th. Beautiful. Example 4, that negative 1 power is only talking about what is immediately to the left of it, so that w to the fourth to the negative first becomes w to the negative fourth, and then nothing happens to that w to the sixth. It's just w to the sixth. What do I have to do to this to simplify? Add the exponents together, we get w to the second. Any questions on this page? Flip it over. Here's where things get complicated. So now I'm not just raising one base to a power. Like all of these only have one unique base. Only p's, only x's, only m's, only w's. Here, I've got a lot going on. So I've got everything in those parentheses is being raised to the third power. So this is like, let's do our expansion. This is like saying I have a bunch of 2's. I have 3 2's. This is saying I have a bunch of m to the thirds. And I have a bunch of n squareds. How many total 2's do I have? How many total m's do I have? I have 9 of them. There's 3 in each space, so there's a total of 9 of them. How many total n's do I have? 6 of them. So is that simplified all the way? We can get rid of that 2 to the third, right? We can make 2 to the third into an 8, and then I have m to the 9th, n to the 6th, and that's simplified all the way. So let's really quick just think about what just happened. What's the quick way that I could have gotten 2 to the 3rd, m to the 9th, n to the 6th? Cody? Yeah, we're going to multiply this exponent to all 3 exponents on all 3 bases. What's the exponent over this 2? It's a 1. When it's not written, it's a 1. So I did 1 times 3 to tell me that this was going to be a 2 to the 3rd power. I did 3 times 3 to tell me that was going to be m to the 9th power. And I did 2 times 3 to tell me that was going to be n to the 6th power. So you are going to, let me zoom out to this rule. When raising a product, multiple bases, to a power, you distribute the exponent on the outside to all of the exponents on the inside. The key part here is we're going to have to make sure that we get every single base inside those exponents. So let's look at example 5. This is where I'm going to ask you guys, how many bases do you see here? I see 2. There's a 2 and there's an x. That means I got to make sure I distribute to every single base. The 2 has an exponent of 1. So 2 to the 1st to the negative 4th would be 2. 1 times negative 4 is negative 4. And then same thing with the z. Z to the negative 3rd to the negative 4th. Negative 3 times negative 4 is positive 12. Is that simplified? What do I still have to do to it? I'm going to take the 2 and I'm going to put it on the bottom because I have a negative exponent. Z to the 12th stays up at the top. 2 to the positive 4th goes to the bottom. Is that simplified? What do I still have to do to it? Multiply out 2 to the 4th. Oops, not z to the 4th, z to the 12th. 2 to the 4th power is a 16. And now we're done. Any questions on that? In example 6, how many bases do we see? 2 bases. I see the negative 3 and I see the x squared. That means I'm distributing this 3 to both of those bases. So a negative 3, let's do this. The negative 3 to the 1st power to the 3rd power is negative 3 to the 3rd. X squared to the 3rd power is x to the 6th power. No negative exponents to worry about here, but I do need to take care of that negative 3 to the 3rd power. What is 3 to the 3rd power? 27 is 3 to the 3rd power. And then that's a negative 3, though. So I have to figure out, is my sign going to be positive or negative? Does anybody remember that rule? Why is it going to be negative? Because my exponent is odd. So if my exponent is odd, our answer will be negative. If our exponent is even, our answer will be positive. Any questions on that? Things get real tricky in example 7. Are we ready? There's a lot of bases here. Each section that's in parentheses is being raised to its own power. So this section right here is raised to the 4th power. This section right here is raised to the 4th power. I can take care of them separately. So let's first take care of that one on the left, the 2x squared to the 4th power. How would I rewrite that? Two to the 4th power, x to the 8th power. Exactly. You're multiplying those exponents. Let's take care of the right side. What does that look like? What does the right side look like? I see 3 bases here, right? I'm going to do 3 to the 1st to the 4th, which is 3 to the 4th. X to the negative 2nd to the 4th. Negative 2 times 4, negative 8. And then y to the negative 2nd to the 4th, also to the negative 8th power. Everybody good on that step? Now I've got a lot of combining to do. So what things can get combined here? What things can get simplified? The x's. What happens to my x's? They don't cancel out. What do they become? X to the 0th power. When I add 8 and negative 8, they become x to the 0th power. Can I simplify 2 to the 4th to be 16? And 3 to the 4th is 81? Does anything happen to this y to the negative 8th? It's got to go down to the bottom. So over y to the positive 8th. And then let's just say I rewrite this x to the 0th power as a 1. 16 times 1 times 18 is going to get me a real big number. That number is 1296, I think. Correct me if I'm wrong. But there we go. Any questions on that? Who can help me through example 8? A little bit easier. Sarah?
You would do 4 to the power of 3, which is 64. And then you do you do negative 2 times 3, which is negative 6. And then you put 64 over m to the 6th power.
Beautiful. Any questions on any of that? Who's got 9? Autumn. Oops. Correct. And why do we know that's a positive 16? Because our exponent is even. Beautiful. Any questions on that one? Okay, let's go through this last one a little bit more slowly. Example 10, I've got 2 big bubbles. I'm going to take care of one at a time. Let's start with the one on the left. I'm going to distribute that 3 to all 3 pieces. 3 to the 3rd, a to the 2nd times 3 is to the 6th, b to the, we can't see it in here, there's no exponent, so remember that's just like b to the 1st, so it becomes b to the 3rd. Same thing over here, distribute to both bases, 5 squared, a to the negative 6th. Help me with the simplifying now. Read.
3 becomes 27 and a6 and b3.
Okay. Then what?
And then 5 to the 2nd can become 25. And then 8 to the negative 6.
Perfect. Next simplifying step. What else can be simplified in here? Cody? The a's become a to the 0th power. Does anything happen to that b? Nope. Can I simplify 25 times 27? What does that get me? 675? And then b to the 3rd. Don't forget that a to the 0th becomes a 1. 675 times 1, b to the 3rd. Any questions?